Welcome to the ABANA National Curriculum Level 2 tutorial series. Session 1 will cover punching and drifting with Mark Aspery.
Welcome to this punching and drifting tutorial. This is a CBA and ABANA collaboration, and I'm Mark Aspery, and we'll be looking at the tooling and techniques of punching and drifting for the next 40 minutes or so. Looking at the left-hand photograph, if we take a typical blacksmith's half-inch round punch and punch a hole in a piece of flat bar, in this case 1.25 inches I think it is, that's our result. If we take the same punch and we're trying to punch a half-inch hole into a half-inch square bar, we're just going to cut the bar in half. So we need a different method, and we're going to look at the slot punch. Using a slot punch, we can control the character of the thickness of the eye material. It does have some limitations, however. If you slot punch into wide plate, then all you're going to do is, as you drift, you're going to push the material away until the material meets the resistance of the plate, and you're going to forge this dam. And then of course you dress the dam and you get back to the slot punch, and so it goes backwards and forwards. So this would be a good application of the round or square blacksmith's punch. As you can see from the top left photograph, the slot punch in this case is too big for the intended outcome. The slot punch there is 1 inch or so wide or wider, and the drift is 1/2 inch, far too much. If we look at the top right, you can see that that small hole, if we want to drift it to 1 inch for example, is way too much work. We could have done a better job. And then the bottom photograph shows the top left photograph having been drifted to a suitable size. So you can see that there must be a relationship between the slot punched hole and the intended outcome. These are two 1/2 inch holes in 1/2 inch square bar, one on the diamond, one on the round. Each required a different size slot punched hole. But let's take a look at a bigger picture. I'm going to get ahead of myself a little by saying in that for the most parts, drifts push and they don't pull. I find that I can go about 1/16 of an inch over size of the drift with the width of my punch. So for me, I make the drift and then I make the punch. There are 3 methods of slot punching and drifting. I can punch and immediately drift, as we can see there. The next would be I can punch, then upset, and then drift. And this is where I'm expecting a lot of the hole. So I'm going to punch long, then upset, displace the sides to come closer to their final resting place, and then I'm going to drift with their final shape, such as these rectangular blockings. And then lastly, for me, you can upset first, then punch, and then drift. So in this case, I'm punching across the corners on square bar, and you can see that I want to hold as short a tool on that corner as possible. If I've got a long tool, then it's going to give me indigestion holding on that corner. So I'm going to upset the material first, then punch, and then drift. And you can see that in this case there has been a deformation of the corner material until the punch receives some form of resistance, and so this will all but get cleaned up, this excess material above the white lines. So that's why we're going to upset, then punch, and then drift. For me in this tutorial, I'm going to look at numbers 1 and 3, punch and immediately drift, and then the upset, then punch, and then drift. Your punch and immediately drift is our typical usage of the technique, from pass-throughs to hammer eyes. But let's take a closer look. This is how we typically use a punch. We punch, take the punch off, check that you're in the right place, and if not, move the punch. And then we continue to punch until we hear and feel the anvil. We turn the bar over and we back punch to get the slug out. I want to take a little closer look at what's happening with this method, because there's another method that we could use. As we punch, there is some migration of material ahead of the punch, and I'm showing it down coming about 45 degrees. But as we punch, there is some material pushed ahead of the punch. Let's have a look at this. Is a hole that is punched all the way to the anvil, turn over, back punch, and then it was drifted from the bottom side going up to be fair to the hole. And you can see that I've got less material on top and more material on the bottom. And this is not a real problem if the finished piece is going to be decorative, for example. But what happens if this hole was intended to become a hammer, where you're going to draw the cheeks of the eye material? Well, now you've got a problem, because you've got to try and dress this to make it equal. So I'm going to suggest that we can have another go. If we punch towards the middle of the bar, then all the surplus material is in the middle, and then we can just spread, in this case, the cheeks of the hammer to make it equal. So I want to punch from both sides of the bar and meet in the middle, and that's where the excess material is going to be pushed. Let's have a look at a drifted hole. So this is punch from one side, turn it over, punch from the other side, and I'm going to say this is very close to being parallel. Actually, it's slightly barrel shape with a little more material across the center of the bar, and that is to our advantage. But that brings another question. What for me is a center punch? When you make a center punch mark for me, this can be anything from a 1/16 to an 1/8 of an inch across the top. So where do you hold your slot punch if you're trying to be accurate with this? On the corner, in the middle? There's a lot of things going on. So for me, when I use a center punch, and I don't very often, but when I do, typically I'll put the tool away from me, so I am standing on the right hand side of this. The blacksmith is standing on the right. The tool goes off to the left. Hold it at an angle, stand it up so just that one corner is touching, pull it back until you feel it go click, and we don't really care where it is, so long as we use the same method over and over again, we'll get the same result over and over again. Once you hear the click, stand it up, give it a whack, see if you're in the middle, and then go to work. But always make sure you check to make sure that you're in the middle of the bar, and trust your eye, not necessarily the center punch. Your eye, I believe, is more accurate. So give it a whack, have a look at it, make sure you're in the right place, then carry on. But then we come into the math side. How wide should a slot punch be? Well, let's have a look at some examples first. So if we look at these examples on the left, this is what we want. This is our intended outcome, in this case something like a hammer eye. And you can see that my slot punched hole is as wide as the drifted hole, and that will give us a nice clean result. If I am too long with my slot punched hole and I am punching and immediately drifting, and remember we can punch, upset and drift, but if I'm punching and immediately drifting, the result is I'm going to see evidence of the slot punched hole post drifting, and that's not what we want. For me, I think I can go about a 1/16 of an inch oversized, but no more than that. Otherwise, I get to see this evidence after I finish my drifting process. Working in a strong light source can be detrimental to getting your punch in an accurate place. If you have any strong light source, be that your lights from the roof, be it a window, be it an open door, try and point your bar to the open light source, and that will help you center your bar. I typically, if I've got a strong light source to the side, I end up crowding the shaded side, and then I've got a bit of a problem. Most times I like to work along the bar. There are occasions when I will work across the bar, but these tend to be for more complex forgings, or unless there's no other way for me to get the job done. Otherwise, I'm working along the bar. To go back to our punch to the middle, turn it over, and then punch from the other side. If I am going to center punch, I only center punch from one side. I'll click, stand my punch up, go to work, drive it halfway through, turn the bar over, and I am looking at the swelling here as the indicators for where I'm going to place my punch from the second side. So if I were to do this in a two-step process, the first thing I would do is I would hold my punch so I am splitting these two arrows. So I've got it in the middle lengthways of the bar, and then I am going to hold it widthways to make sure I'm in the middle of the bar. Then I can go to work. Over time, you'll do that as one motion. You'll just stand the punch up and then just wiggle it back and forth and give it a go. And it works whether you're using flat or square bar, or whether you're using round bar. It's the same thing. So here's our result. Note how the lower hole is slightly longer than the top hole. That's because of that migration of material. And I also want you to see that the slug is slightly thicker than it would be if we'd gone to the anvil. This is a slug produced by punching to the anvil, and this is the slug produced punching to the middle and then cleaning out the slot. I want you to see that I'm starting to get some undercut here. I'm just about to shear this out. But I get a nice clean hole when finished. I get a little bit of rag, but not as much as I would get if I was using, say, something like a slitting chisel. So for me, I'm going to clear the slug over a suitable void. And if your hardy hole is particularly small, you might want to build something that you can put on top of your anvil or mount it in the vise or something like that, so that you've got clearance for your punch. I'm going to drift from the crown side because I'm trying to straighten this bar as I'm working. So we straighten from the crown side. I'm going to drift from the crown side and make sure that your drift has clearance. If you're using a 1/2 inch drift and you're tending to go over the pritchel hole, make sure it does actually clear the pritchel hole. There's been more than once or twice when I've pinned my drift into the pritchel hole because I've been working too fast. If it goes wrong, then you're going to have a thick and a thin side. There are a couple of things you can do with this. If you're dealing with mild steel, you can quench the thinner side, which is going to increase the resistance. Remember, the tool will move to the path of least resistance. So this side being hot, as you punch this hole, the tool will move this material out and you'll recenter the hole. If you're dealing with something that cannot be quenched, a hardenable material, then I will put the thick side down in the fire and cover it with coals, and the thin side will be up and uncovered, so it's not getting that same radiation, and I'm looking for a difference in heat. So when I come out, the thick side should be hotter, again less resistance, and the tool will move to the path of least resistance. And of course, as everything went well, then you're just going to put your hole north-south in the fire and heat it accordingly. We don't care if there is a gradient in heat from the bottom to the top. We do care if there's a gradient in heat from one side to the other. So if your hole is good, orient it north-south in the fire. When you're correcting any bends in the bar, etc., do give some thought to protecting your hole. You might want to put your drift in here, or make a couple of drifts in this case, to fill those holes so that the inertia of this end hanging out in space as you make the blow here doesn't start to damage one or other of the holes. You can, with round bar, get away with a punch and drift, but I recommend a pre-upset. Again, we're looking at the support of the material to offer resistance to the punch. You can do it in the forge, and I do, but if I'm in my own shop, I just grab an oxy-fuel system, as I find that to be a lot more efficient. Let's have a look at that resistance. When we look at the top left here, you can see that on a flat bar or square bar, I've got resistance to my punch all the way across the top surface. Looking at the middle with the round bar, you can see that I've got greatly diminished resistance to my punch. So my punch is going to cause some damage here until it meets sufficient resistance that the sides are supported. And then with the diamond, or holding the square bar on the corners, that's even more. There's even less resistance to my punch, and you can see that as evidenced by the photograph in the top right. I get damage to the material. So both the round and the square bar, if you're going across the corners, could benefit from a pre-upset to help mitigate for the damage. Here I've got a series of holes that were punched without any upset, and you can see that they are slightly flattened between the holes. This is something I use as a handle for a tool or something like that, just to make it not transfer as much heat and just give me something that's a little more tactile. Staying with round bar, after the initial upset, this bar was punched with the support of a half round bottom swage, as shown in this bottom right photograph. The bottom swage is a level 2 curriculum project for both the CBA and ABANA. Make sure that your half round is at least 1/8 of an inch or more larger than your original bar, and that's because you've got to accommodate 1, the upset, and 2, the resultant swelling caused by the punching action. This is the same rules. We're going to punch from both sides using the swelling as the landmark, and we're going to use the half round bottom swage. Now this is going to sound very Californian, but as you punch, I want you to try and look through the bar and see where your punch is going to come out, and I want you to steer the bar or the punch to help change the place if it's in the wrong place. You can do some good work with this bar just tucked between your legs, but if you want to have more control, if you're not feeling like you've got enough control with the bar at this stage, get one of those quick clip vice grips, the ones that adjust quite quickly, and clip that on so that you can hold that between your legs, and that will stabilize the bar considerably. In this case, I'm drifting to shape over the Pritchell hole, and once the tip of the drift pokes through the bottom of the hole, I pull and push the stock between hits. So I'm trying to support all sides of the work. So I will hit it, bang, pull. So I'm supporting this side of the work, hit it, bang, push. So I'm supporting the opposite side of the work, hit it, pull, push, etc. Punching across the corners on square bar will of course require the pre-upset and will require a V-shaped bottom swage. Again, another level 2 project. Take a moment to look at this picture. Note how having the flat bottom to the slot punch is an advantage here. If I had something like a slitting chisel trying to hold it on that sharp edge, it would be causing me a little bit of difficulty. I also want to note that we know there is going to be some damage to the corner anyway because there's not enough resistance to the tool. So why don't you take your time and just give a slight tap to the edge with your hammer and create a very slight flat spot. And now you've got something that you can put your slot punch on. And that goes a long way to helping this thing get in the middle of the bar. Here's the result of my punching, and you can see I'm reasonably on with my center line. You can see just a slight damage either side the hole. That's where I touched it with my hammer just before I landmarked with my slot punch. And again, I punched into that V-shaped bottom swage. If we look at this coffee cup and a teaspoon here, you can see that the tip of my teaspoon is not quite in the center line of this bar. And as I push on the teaspoon, you're going to see that the teaspoon is going to be deflected away from the rim of the cup in this case. And so it is with a slitting chisel. If I take a slitting chisel, and you can see the angle of my cutting chisel there and the slitting chisel, if I'm not absolutely dead nuts on that edge, then as soon as I'm starting to punch, it's going to behave like a screw. It's just going to shear off the cutting edge. So I'm a big fan of the slot punch, and if you're going to use the slitting chisel, again do the upset and then just damage the edge slightly to put a slight flat spot on it, and that will give you a few less grey hairs. This is me drifting the punched across the corners, and I'm going round, and I have got a bolster here that I've made, and you'll notice I've relieved the edges in the bolster just to allow this material room to move. Let's have a look at the bolster. So I started off, I believe this is 2-inch square. I hot cut down the middle and then pushed the sides out and finished off with a piece of square bar and created a V. And then I came in and I first of all relieved the edges. Looking at this top right photograph, and you can see there's a flat spot in the middle, and one's in the middle and one is off to one side. This is for a perpendicular hole and this is for an angled hole on the right there. So I removed a bunch of material with my ball peen, and then I came in with a cone shaped tool, and actually I use a ground knuckle on a piece of sucker rod for mine, but whatever it is, just create that cone shape and then put your typical round blacksmith punch in the middle, give it a slight tap, and that gives you somewhere now that you can rest a drill on. If you leave it V-shaped in the middle, then the drill is just going to catch the edges. So you're going to drill this and then you're going to drift. We'll get to that in a little while. So if you are liking the punching to the middle of the bar, then there are some advantages that this offers you. If we punch, turn over and go penny on a penny and punch from the second side of the bar, we're going to get a perpendicular pass through. If we offset the punches too much, we're going to get nothing. We've made a mistake. But the third option is if we just offset them fractionally, we can have a shared common slot, this bit in between the A and the B here. And we can drift this whole thing out to make a pass through on the angle. Typically for me, this gets to about 27 to 28 degrees or so, so not quite sterile stuff, but enough for decorative elements on window grills, etc. Let's have a look and see what's going on when we do this. So this is me, I've punched from one side, that's on the bottom. I've come in and punched from the second side, and you can see I've got a slug here ready to go. So you are going to need a second slot punch to clean out the slug, or your drift has got to have a slot punched end, and then you can drift. I have two separate tools. So I've got a smaller slot punch, I clean out the drift, I clean out the slug, and then I go to drifting, and here is my drift. And one thing I'll say about drifts is the working end of the drift, that's this bit, the working end of the drift must reflect the size and the shape of the hole that you intend to resize and reshape. So if I was just going, if I had a set of holes that were penny on a penny, then my drift could be 1/2 inch wide at the working end, no problem. But in this case, because I've offset the holes, then this drift is 1/4 inch, for example, and so it'll fit in that slot punch, and then it is going to push the common slot, the material of the common slot, out of the way, and we're going to make our angled pass through. Let's have a look at it at a full bar. Here's the slug ready to go. I come in the top right, I've cleaned the slug. Here it is in a different viewpoint. And yes, I'm going to have evidence of those steps from one side to the other. So this is a hole that is intended to be filled. But if we continue the same method and the measurements, we can get the same results across multiple bars. So we can get square bars, round bars, flat bars, whatever. So long as we do the same offset and carry on with the same technique, we've got a predictable outcome. What I want you to note here is that the bar is a good fit to the parent bar. The pass-through bar is a good fit. So we've managed to drift that shared common slot to the same size as the outside holes. The only way you're going to get this done is if the bar is smoking hot, and you may need to drift over 2 heats and drift from 2 sides of the bar. Here are 2 heading plates, one for round drifts and one for diamond drifts or diamond holes on the angle. And so what I want you to note is the 2 of them, and they're facing in opposite directions, and that allows you to work from one side of the vise rather than having to go from the other side of the vise. If you start with an angled hole and put a drift in, if you turn it over, you'll notice that the hole runs the opposite direction, and so that's why there are 2 of these holes facing each way. This little lump on the side of the top right photograph is a little tab I've welded on, in this case probably inch or 7/8 or so I can clamp that bit in the vise, giving me clearance for the drift as it goes between the jaws of the vise. In this case, to get the diamond shape, what I've done is I come to a piece of scrap bar and I've drilled 3 holes of different sizes, just under 1/2 inch, and just over, or something like that. Actually, it's probably the other way around. This right hand side will be 1/2 inch or 7/16, this will be 1/2 inch, and this will be 9/16. And then I run my drift through and I see which one gives me the cleanest hole, and that then is the size of the drill hole that I put in my V-swage when I'm making it for punching bars across the corner, or when I'm drilling this to make this angled hole on the diamond for across the corners, etc. How do I make them? I take, again, it's a 2-inch bar, I drill my clearance hole. So I've already done my experimentation with that last slide. I'm going to drill my hole. I'm going to cut a couple of pieces off at the desired angle. So whatever angle you want, I'm going to say the maximum is 27 or 28 degrees, so less than that. If you want more than 28 degrees, you're going to have to come up with another method, and I'll touch on that slightly in this show. So work out your angle, cut these pieces, 2 of them, off at the angle. You're going to put them together end to end, and that's going to create a V that you can fill with weld, or at least I can fill with weld, and then you are ready to go. Weld your tab on. Another way you can deal with this is a Dialodex type thing, where you've got something, in this case the distance between the center of that bolt hole and the center of this hole is the same distance as my Pritchell hole to my Hardy hole. So I can actually use this on my anvil, and I can just dial up the hole that I want. Notice I've got a little chamfer on the edges here. Dial up the hole and then just use that as my heading plate. So let's go back to the slot punch. You will have covered the slot punch in your level 1, but just to make sure we're covering all the bases, this is what we're going to do. We've made the struck end. We know that this typically is 3/4 inch wide bar, and if I just flatten that, I'm going to have something that is wider than 3/4 inch bar. So if I want something that is going to be constrained, the first thing I'm going to do is take the excess material out. Now, my punches, I like the working end to be perpendicular to the indexing. That is, it's 90 degrees to the indexing. That's when I'm working along the bar. If I'm working across the bar for complex forging, then the working end may be parallel to the indexing. So in this case, I'm taking a standard slot punch, which is perpendicular to the indexing. I'm going to remove some of the excess weight forging in parallel to the indexing. Once I've removed some of the weight, then I'm going to forge perpendicular, and I'm going to start to create my punch. And you can see the top right here. Here's my indexing, and then here's me drawing down over the bick. Once I've finished with the bick, I'm going to come to the flat face of the anvil. Leave yourself a little bit of room for cleanup, so don't try and constrain it too much. I'm going to flatten the sides. Once I've got the sides somewhere where I need them, I'm going to come in and I'm going to knock the edges off. There's no room for sharp edges on a slot punch because they're just going to be stress risers, something that's going to cause a crack when you start drifting later. So I knock the edges off, and then I'll come in, run my hammer down the sides and the face, and make it the best thing that I can. Remember, anything that penetrates the bar, be it a punch, a chisel, or a drift, anything that penetrates the bar, friction is the enemy, so make these surfaces as smooth as you possibly can. For me, in my shop, and I don't have an abundance of electric tools, I'm going to just cut off the end with, in this case, a butcher chisel, making it fairly square, and that's going to save me a whole host of filing or grinding. And then you'll notice I've come in and I've re-relieved those round edges, so it truly is a half round on the edge. And I'll take that up to inch, inch and a quarter, inch being the maximum bar that I intend to hand punch. If I need a hole in something that's wider than that, then I'm going to make a rodded or a handled punch and use that, keeping my hand away from that big bar. Let's have a look at the drift. Drifts are like dinosaurs, of course. They are thin at one end, much thicker in the middle, and then thin again at the other end. Well, yeah, thank you very much. So let's take this. I'm going to upset this. Typically, I go to about 4.5% of the diameter. This being ½ inch, I think that's 25 or 26 thousandths or so. Don't get married to the numbers. It's about 4 or 5 clouts with the hammer, and that should get you there. You'll notice that my upset is off-centered. That's because I'm going to have the shorter end is going to be my struck end, and the longer end is going to be the taper to the working end of the drift. Now, in theory, it shouldn't matter which one you draw down first. In practice, it really does. I do the struck end first because that's shortest. Once I've got the struck end, I can typically reach around that with my bolt jaw tongs and grasp this round centerpiece as I draw down the taper for the working end. If I do the long taper first to the working end, that working end may interfere with the jaws of the tongs and will prevent me from getting a secure grip around this round piece as I draw down the struck end. So I make the struck end first and then I do the working end. Let's have a look at those. So I'm just making a quick octagon, and then I use if there's any bend in the bar here, use the opportunity of making the octagon to try and straighten out the bend. Don't try and whack this because you're going to put a ding in your nice round drift. As soon as you've got the struck end done, turn it around and you can see that you can reach around the struck end and grab the round portion of the stock. And I'm going to draw this out over the bick. Don't forget, the working end of a drift should reflect the size and the shape of the hole that you intend to resize and reshape. In this case, I'm going for something that looks like a 1/2 inch hole, so I don't have a great degree of taper on the end. I do want you to relieve these corners heavily. And what I'm saying here is that sometimes the diagonal measurement across the corners, even though it's a taper, that diagonal measurement can be in excess of the main body of the drift. So make sure that you spend your time getting those corners removed. If we want to look at the diamond drift quickly, this is why your blacksmith instructor was big on telling you to keep the taper in the middle of the bar as you work. So I do a short taper, I'm going to turn it on the diamond and I'm going to flatten this. If this taper, look at the top right photograph here, if this taper was left or right of center line here, not up and down, just left or right, as I flatten this, it's going to be left and right on this stage. And then I'm going to have to hit this with my hammer, destroying that nice edge to try and bring this back into the center. Much better if your taper was centered before you start. And in this case, you can see that I've got the bottom side of that corner there is thinner, the top side is thicker. So you can see I was holding my hammer at a slight angle, or the work at a slight angle. It seems to be something I can produce every time I try and make one of these things. So I'm going to have to get busy with a file and just clean this up. I'm looking at that diagonal measurement for my slot punch, so I measured that, and so for a 1/2 inch hole, that typically is about 3/4 of an inch. You can add a 1/16 to that if you wish. I typically don't with these diamond ones because I'm relying on that corner cutting a little bit. So I'll go 2 spec 3/4 of an inch, and then with my drift, and here's the corner that we laboured to keep. The two sides are uniform. And I'm going to drift over the hardy hole. As soon as I've started the drift and it's come through the other end, I'm going to reach for the bolster. This is my bolster. I'm going to continue to work. And this is one of the times when I work from both sides. Because this is a precision fit, if I push through any material, it's just going to get sandwiched on the side and I'm going to have a flashing. So I'll work a little bit from one side, pushing material to the center, turn the bar over, work from the other side, again pushing material to the center. Try not to let any excess material come out past the edges of the bar. Now if you look at the top right, we can clean up this hole on the edge of the anvil, and if you just got 1 or 2 to make, that's an excellent way of doing business. If you have a lot of these to make, then we're going to make some top and bottom V swages, again level 2 project. In this case I've taken my bottom tool, just full it in the corners and put a piece of 1/4 inch round around there, and so it's rodded, and that's something I can hold with my tong hand as I go to work. So let's have a look at the slitting chisel, as we've mentioned that a little bit. Here is my slitting chisel. I'm in the center of the bar. I'm going to punch from both sides, so I punch from one side, I turn it over, and remember we said there's a migration of material ahead of the punch. So as I punch from the second side, look what's happening to that chamfer, if you like, at the bottom of the chisel, on the bottom cut. It is starting to get flattened. So the more I work, and I'm got this big photograph here, the more I work, the more this becomes flattened in such a way, and you can already see that I have got undercuts here on the bottom edges of that bottom slot. And my result, this is my slitting chisel, is I have this rag. If I look at a slot punch doing the same size, you can see I have a little bit of rag, but it's definitely nowhere near that of the slitting chisel. So going back to our slitting chisel, here's the result. And when I drift this, unless I take steps to remove this rag, get in there, the blue brittle with a chisel or something and chip them off, then I end up drifting the rag and not drifting the slot punched hole. So I don't get the outcome quite that I wanted to. And so this is the end of the tutorial? No, I don't think so. Once you get good with your punching your holes, I think that the punching and drifting is just the beginning. Now you're looking at your design. One last thing I will mention is if you're punching to accept a tenon, for example, then punch from the rivet side. That's going to suck the material from the rivet side, leaving a slight concavity, but it's going to give you a nice square shoulder edge for your tenon. So punch from the rivet side going towards the square shoulder. And that concludes this presentation.
Thanks for watching, and be sure to subscribe to be notified when future videos become available.